Today we're just going to be kind of continuing with some of the Python fundamentals. We basically kind of covered most of everything. There's just a few more things we're going to do today. And then we'll actually start doing some actual data science using everything that we've learned so far. And actually look at some actual data sets. So it's going to be pretty cool. And that's going to be kind of the bulk of the rest of the class, hopefully. Yeah, you guys are pretty much like in a good shape now to actually start kind of manipulating data, looking at just different types of tables and manipulating the tables. So that's kind of what we'll be doing today. A few announcements. So quite a few actually. So we have this new page of supplemental videos, so you can click it directly from the slides. So these are just videos that we actually filmed a few years ago when the course was completely online. And so those are just kind of additional materials that maybe go into deeper context, or maybe just use different examples or different analogies. So sometimes it's helpful. It's not something we'd consider kind of the core of the class, but it is a good way to kind of just get additional materials and explanations. So Vitamin 5 is out. Please complete that before Wednesday's lecture. Homework 2 is out, due next Thursday. So this is going to be kind of the normal thing. So every Friday we'll have the homework out, do it the following Thursday, submit it Wednesday for extra credits. And then tutoring sections are now up, so you can sign up for them. Check out Piazza for the link. And they begin on Tuesday. And then lastly, there's no lecture or discussion on Monday due to the holiday. And so if you do have discussion section on Monday, please attend one of the discussion sections on Tuesday or Wednesday. And I believe you can just kind of pop in, because they're gonna expect that people are gonna be coming in. So you don't need to necessarily email them ahead of time. And because you have the day off, please, if you have the privilege to do so, register to vote. So just a reminder. All right, so today we'll be talking about arrays. So in the last lecture on Wednesday, we talked about kind of all the different data types in Python. So we went over integers, floats, strings, which is how you represent text in Python. And then today we'll be talking about a new kind of structure called arrays, which is what is going to be used pretty much every single day in this course. And it allows you to store a sequence of values. So the best way to do this is with some examples. So first of all, how do you create an array? So you create an array using the makeArray function. And then you just pass in the values that you want in your sequence. So let's say I want to store 1, 2, 3, 4 in a sequence. I can add this to, assign this to the name myArray, and then I can just look at what this is. And so you can see here it says array 1, 2, 3, 4. So this is how we create an array. And then what's cool about arrays is that you can do operations on them that are automatically going to be done to all elements of the array. So for example, if I want myArray times 2, everything in the array gets multiplied by 2. So now we have 2, 4, 6, 8. Similarly, we could do like exponentiation. So we could do myArray and then squared. So everything in the array will be squared. And so you see 1 becomes 1, 2 becomes 4, 3 becomes 9, and so on. And then you can also do addition. So you could do myArray plus 1, and that's going to add plus 1 to each element of the array. So now we have 2, 3, 4, 5. So these are kind of different things you can do. And so again, an array is just a sequence of values. And the important thing about arrays is that you need to make sure all the values that it contains are of the same type. So like they need to all be integers, or they need to all be floats, or they need to all be strings. That's the most important thing. And so we're going to use these again and again. The most common use case for us is going to be columns of a table. So in a table, you might have like a bunch of values of a particular column. Typically, all those values are going to be of the same data type. And so an array is kind of a good way to store all that data, that sequence of values. And so I've written it here as like a sequence of numbers like this, but really it doesn't have to be like numbers that are increasing. It can just be any random set of numbers. But really it's just kind of like a collection of numbers. That's really all it's doing. And then do you need to import a specific module? Some people are asking this question. So makeArray does come from the data science module. So we haven't really covered this too much so far in this class, but we do have these lines that run at the top. And so we say from data science import star. And so there's some things that are just built into Python, such as like doing 2 plus 2. You don't need to import anything to do that. But to use special functions like makeArray, or to use things like the table that we've been using, the data science table that we saw last time, we need to use a data science module. And so this is how we import stuff from the data science module. So what this line is basically saying, from data science, import everything. So the star just means we're not going to specify a specific part of that, of data science that we want to use. We just want to use everything in data science. So that's what's happening there. And so that's how we were able to use make-array. Cool. And then some other functions that you can use with arrays. So you could check the length of an array. So we do this using len, len. So length of this array is 4. And then we can also sum up all the values. So we could do sum of my array. So this just sums up all the elements of the array. And one thing to keep in mind, actually up here, is we were doing these things, my array times 2, my array squared, my array plus 1. But keep in mind that none of these lines, these 3 lines here, 5, 6, and 7, actually manipulate the array. So if I check the value of my array again, it's still 1, 2, 3, 4. So that's just really important to remember that when we do these operations here, it's returning back kind of a copy of the array that's been modified. So it's basically returning a brand new array. Our original array has not been modified yet. Yeah, to clarify length of my array, this is just going to return how many elements there are in the array. So this array has 4 elements, so that's why it returns 4. Okay, and then we can combine these functions together to do something even more interesting. So let's say we wanted to find the average value in a sequence of numbers. So we could take the sum of the values, and then we could divide by the number of them. So take the sum, divide by the length, and that gives you 2.5. So that's the average value of all of the elements in the array. And then there's a new function here that we're going to tell you called np.average. So there's another way to do this with just one line, or like a simpler expression is np.average my array. So it gives you the same result. All right, and then so yeah, I mentioned arrays can have kind of anything. It doesn't have to be just a sequence of numbers in order. So we can make another array here with just some other kind of values that are not in order in any particular order, and that's totally fine. I'm not sure what happened here. Oh, sorry, I wrote my array. Should be make array. So another equals make array, and then the value that we wanted to. And so if we have another array, we can actually add 2 arrays together. So we could do my array plus another, and that's also fine. So 70 is going to get added to 1, 60 will be added to 2, 90 gets added to 3, 80 gets added to 4. So you can add 2 arrays together. So yeah, there's quite a few questions about length and arrays and lists. I'll just let them, Professor Wagner answer those questions. All right, so now we have 2 different arrays. We can add them together. So that's a really common thing that we'll be doing with arrays. Another thing you can do is make arrays of strings. So this is going to be super common. We're going to have, in data science, we'll have data sets where you have a column with all the data types being a string. You know, it's like names of people or like names of a city or a state, whatever it is. So we can do that here. So we can make, let's say, I'm going to call this tunas. And so this is going to be an array of different kinds of tuna. So we have bluefin, albacore, and gin. And then we can print out tunas. And so this is just going to return kind of the values that we have in our array. But one thing to keep in mind here is that if I do tunas times 4, so that worked up here, up above. We were able to do my array times 2 at the top here. If we try to do that down here, it actually doesn't work. And the main reason is because you can't multiply strings. So you know, this just doesn't let you do that. And so that's one thing to keep in mind, is that even though these are both arrays, it kind of depends on what data type you have in the array. And so I've seen some questions around what is this D type, and it says like U8 something here. So you don't have to worry too much about what this means. This is just kind of Python's internal representation of what a string is in this particular case. And so it's saying that this is an array with a D type U8. That's just kind of like an internal way of saying string. And then if you look at this error message again, it might be kind of complicated. You don't need to worry too much about everything that it says here. but it does say like multiply did not contain a loop. Not sure what that means, but with matching types, D type, U8. So basically what it's saying is you can't use multiply with this type of data. And in this case, it's a string. So that's kind of why it's not working there. Cool, and then one last thing to show about arrays is that you can also get a particular index of the array. So you could do, let's say tunas.item. And so let's say I wanted to get the first item of the array, I would do item 0. And so this returns bluefin. And so in Python, you have to actually start the index at 0, not at 1. So item 0 actually returns the first element. And then item 1 would return the second element. So item 1 gives you albacore. And so you have to just be careful. If you try to do like item 3 here, in this case, there's 3 elements. And so item 3 actually means the 4th element. And so if you did that, you would actually get an error. It says index 3 is out of bounds. So basically like there is no index 3 in this array. The array is smaller than that. So that's just one thing to kind of keep in mind. Oh, can you add and multiply arrays of different lengths? That's a good question. So let's actually, let's go back to this example. So let's say instead of this 70, 60, 90, 80, we just did 70, 60, 90. So now this, another has a length 3. I'm just going to show you here. And our original array still has a length of 4. And so now if we try to add them, we get an error. And so again, this error message, it's good to try to see what it's saying. And it's totally fine because you're not going to be able to understand everything that it says. And that's not really the point here. But you says something that says operands cannot broadcast together with shapes 4 and 3. And this is basically saying that these have different shapes. And so they can't be kind of added together here. Yeah. Oh, can you have duplicate values in an array? Yeah, for sure. So that's a good question. Yeah, you can totally do that. So we could do like 90, 4 times if we wanted. That's totally fine. And that's going to be really common. When you're doing like surveys, many people will give the same response, right? So it's going to be very common to see the same value repeated in an array. It's very, very common. Can you add 2 string arrays together? Yeah, we can do that. So if we do, well, actually, you can just add it to itself. Just reload it faster. Oh, actually, maybe you can't then. Yeah, okay, so I guess addition is also not supported for string arrays. Interesting, okay. And so yeah, we can try to interpret this error message in the same way. So this says add did not contain a loop. So it's very similar to this error message down here. So basically it's saying you can't add 2 string arrays together. I know this might seem a little bit silly because in the last lecture we talked about how individual strings you can add together, individual strings you can actually multiply. We did that example where we did like, I think it was like ha times, like 10 or whatever, and then I did that. So string is able to do that, but when you do it with arrays, it doesn't like it. So some subtle differences there, just try to kind of keep in mind. Cool, any other questions about arrays before we continue? How did you take the average? So there were 2 ways that we took the average. One was we called this function np.average. And what does this mean? That's also a good question. That's a fair question. So np is another module. So just like data science, there's another module called numpy. We actually imported it up here. So the second line, we said import numpy as np. And so what this line does is it brings in the numpy module. So the numpy module is another module that someone's written that has all kinds of numerical computations. And one of the computations is taking the average of an array. So someone's made that. We're importing that so we can use their average function that they've created because that's not built into Python. And then what we're saying is we're going to have a nickname for this module. We're going to nickname it as np instead of numpy because I don't want to keep typing numpy.average, numpy.whatever. So this allows us to just write np.average. So just makes the notation like a little bit easier. So that's all we're doing there. So basically this is basically saying let's take the module numpy, let's grab the average function from it and call that on the array myArray. And so this was just a faster way to take the average. And internally, like what is it doing? It's basically doing what we did up here, kind of split up, but it's just doing it for us in one nice kind of expression. And so here we took sum of my array and then divided by the length of my array. That gave us the average. Because if you the average of a set of numbers, you sum them up and then divide by how many there are. So that's why we did that. Who makes modules? Basically, anybody can make a module. Like the data science module was made by the professors who created this course initially a few years ago. So really anybody can make a module and you can kind of publish it out there for the world to use. That's kind of the beauty of Python. So there's just like thousands and thousands of modules for all kinds of specific use cases. Okay. I think I'll try to move on just for the sake of time, but I'm sure Yanai or Professor Wagner will ask or answer some of the other questions that are out there. So I mentioned one really powerful use case for arrays is looking at columns of a table. And so it turns out the columns of a table are essentially arrays. And so we had this NBA table that we looked at last time. So we're just going to read it in again here. And we're also going to look at just a specific team, the Warriors. So we'll do NBA.where team equals Golden State Warriors. So we saw this kind of .where method last time. So we're just going to use that here. So we read this in. I just show you what this looks like. So this is just the players on the Warriors. I think this is from the 2015-2016 season. So it's a little bit outdated. And then we have the positions, the team, the salary. And so we talked, I think, last time about using the select method. So we talked about where, which lets you filter different rows. And then we talked about select, which lets you select different columns. So if you do warriors.select, let's say you do select salary. So this actually returns a table with just one column selected. So this isn't actually a column. It's technically a one column table. And then we can verify this by using that type function we talked about last time. So if you do type of this guy, we get data science.table.table. So this is a data science table. But if we wanted to actually get the column of it, there's actually another function you use called column. So slightly different. And so if you do warriors.column salary, now we get just the values that are in that column. And lo and behold, it's an array. And so now we've kind of really taken it out as its own set of data. And so this is an array. So notice how here there's no context. Like we don't know what this column is called anymore. Whereas over here, when we did warriors.select salary, we had this salary at the top. So this is still in the context of that table. It's just a table with one column. Whereas in this one, we don't have like a label or anything like that. We don't know what the name of this set of data is. We've removed that context. It's just the numbers. And so that's the purpose of column. And so once you have an array, that means that you can do all kinds of operations on them. That's kind of why we would want to do this. And so we can do some of the operations we were just talking about above. So for example, if we wanted to see like the average salary of somebody on the Warriors, we could just do np.average and then pass in warriors.column salary. And this would give us 6.72 million. And so that's one way to kind of use arrays in that context. So before going on, I'll just stop for a couple more questions. Can arrays have different data types? No, they cannot. So arrays, they all need to be the same data type. So in this case, they're float. In this one, they're all floats. So it's really important that every single element is the same data type. Okay. What does relabel 3 salary mean? Yeah, so I kind of stuck this in there. What this means is, so actually I'll try to go over this really quickly. So if we have the NBA table, if I don't do anything, and I print it out, so notice this column it says like 15 to 16 salary. I just wanted to simplify the name of that column. So I said, let's relabel 3 to salary. And again, we do 3 here because Python is indexing starting from 0. So the 0 column would be player, column 1 index corresponds to column position, and that's why the 3rd index is actually the 4th column. So that's what that's doing. So it's just saying relabel the 3rd index column to salary. Cool. So just kind of a recap. So the point of an array is it contains a sequence of values. All elements of the array should be the same type. And then you can apply arithmetic individually to each element of the array. And then if you add arrays, it'll add kind of the elements together, element-wise. So we saw that with the two numerical arrays. So when we added them together, each individual element got added. And so we had like two arrays of length 4, we added it together, still had an array of length 4. Just the elements are the sums of the corresponding elements from the other two. So yeah, you can't add string arrays, but you can add integer arrays, that's fine. Or like float arrays, that's fine. So you can do that. And then we just saw how a column of a table is an array as well. All right, so that's arrays. One other thing related to arrays is ranges. So it's going to be really common for us that we're going to want to be able to create arrays that are literally just a range of numbers. And so, for example, let's say I wanted just 0 through 6. So 0, 1, 2, 3, 4, 5, 6. So let's say I want that in an array for some reason. And so this is one way I could create that. I could write this all out, but it's a little bit tedious. And so one thing we can do is we can use a function that does this automatically for us without kind of being error prone. Because I could have made a mistake here, right? As I was typing this out, I might have typed like 3 twice by accident or added an extra comma. And imagine if I wanted like an array from 0 to like 100. This would be crazy. It would just take me forever. So thankfully, there's a function that lets us do this really easily. And there's a few different ways to use it. And it's called np.arange. So again, we're using that Numpy module. And here using a new function called arange. And so what we're going to do here is we can just pass in the number of elements we want in it. And it'll give us an array of numbers from 0 up to, but not including that number. So if I did np.arange 7, it goes from 0 up to, but not including 7. So if I do like, let's say 15, it'd go from 0 up to, but not including 15, so 14. So that's one way to use it. Another way that's pretty useful also is, maybe you want to range from like one number to another, and you don't want that first number to necessarily be 0. So you could also do that. So you could do np.arange, let's say I want to go from 5 up to, but not including 11. I could do that as well. So you just pass in 2 numbers then. And so that's what this will do. So this gives us 5, 6, 7, 8, 9, 10. So there's another way to use that function. And then the third way to use it is you can make a range of numbers from one start to one end and do it in increments other than just 1. So what that means is, let's say I want to go 0 to 20, right? But instead of going 0, 1, 2, 3, 4, 5, let's say I want to skip by 2 instead of by 1. So I could do that, and that's a third argument. So I'd pass in 2 here, and then I get np.arange 0 to 20 in increments of 2. So now it's going to look like 0, 2, 4, 6, and so on. So that's another way to use np.arange. And so what's kind of interesting about this is that, this same function has been used in kind of 3 different ways here. And in this case, it has 1 argument. In this case, it has 3 arguments. And so we're going to see this a lot with functions. They can have multiple arguments. Some of the arguments might be optional. And so this is a good example of that, where you can include the other arguments if you want, but you don't have to. So any questions about arange? Okay, so I have a question for you. If I have this range, now it cuts off at 18. What could I do if I wanted to include 20 as well? What would I want to type here? Okay. So a lot of suggestions for 21. Let's try that. And so that does indeed work. So you don't actually have to do 22. It might seem like you maybe had to do 22, but you actually don't have to do 22. So 21 is fine as well. And so basically, again, it's literally just doing what I was saying. So it's 0 up to, but not including 21 in increments of 2. And so what that means is let's go from 0, let's keep adding 2 until we get up to, but not including 21. Therefore, we're going to get to 20. And so this suffices to get to 20. Other thing is you can also do, I'll just show this, but you can also do increments of decimal places too. So you could say 0 to 21 in increments of, well, actually that's going to be a lot. Let's do 0 to 1 in increments of 0.1. So then that does 0, 0.1, and so on. So you can do that as well. Cool. All right. So that's ranges. So again, range is essentially an array of consecutive numbers. So very specific. It's a very specific use case where you specifically want to have consecutive numbers. And so there's three ways to use it. The first way we saw was if you just pass in one argument, which is just kind of where you want the range to end. So it's going to be from 0 up to, but not including that number. And then you can specify the start and the end, in which case it'll be the start up to, but not including the end. And then you can also do start and end, and then it's called like step size. So it's kind of like by 2, by 4, by whatever. And so that's from start, and then keep adding the step size until you get to just before the end. So those are three ways to use that. And yeah, so in all these cases, always includes the start, doesn't include the end. And so this first one where you just specify the end, that's basically just like saying the start is 0. So it's just always what it means. So if you don't specify the start, we're just going to assume the start is 0. So that's what that's doing. So that's ranges. And so we'll go into kind of now different ways to create a table. We've already seen one of them. We're going to see one of the other ones as well. So the first one that we have seen with the NBA example is table.readTable. This is one way to create a table. So if you already have a spreadsheet with all of your values in it, then you can just read that into Python and import that kind of as a table. And so that's how we do that. Alternatively, you can create a table from scratch, which we're going to show right now. And that's using the table method like this. So you just use table, which creates an empty table. And then we'll go through how do we actually add things into the table. These are the two main ways we're going to be using. So let's go through how we create it from scratch. Let me make this a little bit bigger. All right, so let's say we want to make a table that just has like some streets in Berkeley. So first of all, let's start by making an array. So we'll do streets equals make array, and we'll put some of these streets. So Bancroft, Trent, Channing, paste. All right, and so we can just look at what this is. So streets is an array containing these strings. All right, and so now we have this, and we want to make a table with this as one of the columns. So how do we do that? So we talked about how if you just do table, if I do this, it just returns like nothing because it's an empty table. There's nothing inside this. And so if we want to actually make it into a table with this array as one of the columns, we can do table with column. And then we're going to give this a name, Southside, let's say, since these are streets on the south side of campus. So we can do a table with column, and then we specify the name of what this column is going to be. So we're going to call it streets. And what are we going to pass in? Well, we're going to pass in our array streets. And then we can just take a look at what that actually is. And so now we have our table. So we've just created this table from scratch. It has a column streets, it has these values inside. And so that's how we can do that. And then let's say we wanted to add another column which contains information about how far away each of these streets are from campus. And so we could maybe add another column called blocks from campus, which just tells you how many blocks each street is from campus. So the way you do that is you can do south side, and once again, you do with column. And in this case, let's call it blocks from campus. And then I'm just gonna add how far away each one is from campus. So Bancroft is like basically on campus. There's 0 blocks from campus. So that's 0 away. The next one's 1 away, next one's 2 away, next one's 3 away. And so this is one way to do this. And so now we would have a table with 2 columns. So we had this original table south side, which has the names of the streets. And we said, let's make a table south side with column, this new column. And what's one way I could have done this a little bit more efficiently instead of typing it out so much? np.arange, there you go. So np.arange, and what would I put inside? 4, okay, cool. So again, we were just doing 0, 1, 2, 3, but instead we said we wanted to do np.arange up to 4. It's the same way as writing this, but it's just a little bit cleaner. So if you run this again, now we have a table with 2 columns. And so the first column is streets, second column is blocks from campus. Okay, now this is a good question. Did this actually change the south side table? Yeah, that's a good question I should ask the rest of the class. Did this line actually change the south side table? Cool, okay. Most people are saying no. So let's check. All right, so indeed, south side is still the same as it was before. It's that one column table that we made up here. So if we wanted to actually update south side to have this new column, we'd have to do south side equals and then everything we just wrote above. So I'm just pasting that down here. So we need to do south side equals outside with column blocks from campus. And so if you do that and then look at south side, now south side has 2 columns in it. So yeah, just to kind of recap, basically starting up here, we use this table function, which creates an empty table. And then we called with column on it, which adds a column to it. Well, rather than adding a column to it, it returned a new table with a column attached. And so it said, this is basically saying, let's take an empty table, let's return an empty table with a streets column attached to it, and then assign it to south side. That's what we did here. So now south side is a table. This is a table, not an array. And it's a table with just one column. And then we said, okay, now we want to create south side with another column. So we just called with column on that table again, except with a new set of data. And so you can just keep calling dot with column again and again on any table. Nice, very good question. Can you create multiple columns in one line? For sure. So here's how we do that. So we start with table again. So this is always just kind of like the kind of blank state. This is an empty table. And then we do with column. Actually with columns, sorry, because it's going to add multiple. And then we can just specify which columns you want. So we can do streets, that's just streets. And then the next column is going to be blocks from campus. And that's going to be np.arange 4. And so this is one way to do it in one line. And then just run this and boom, we got it. So that's kind of a nice way to do it. So, it's up to your preference how you might want to do this. The way we did it up above is nice in some ways because it's kind of easier maybe to kind of see the progression of things. But if you're comfortable, you could also do it this way too. That's fine too. Both are equally valid. Why do we need the end parentheses on the new line here? We don't need it on the new line. I just did it here to make it a little bit easier to read. Really what I did was if you put all this on one line, that's what I did. So you need this end parentheses here because you had a parentheses at the start here for with columns. And I just kind of split this up on multiple lines to make it a little bit easier to read. So this is going to be really common in Python. You'll see many people do this. Just makes the code a little bit easier to read. So that's how we create tables from scratch. Cool. Oh, why is streets listed twice? Good question. So initially here it's listed as a string because that's the name of the table. And then here is the actual name that we use to store the information in streets. So if you remember, if we scroll all the way up here, we had made this array called streets, which had the names of the different streets in Berkeley. And so that's an actual variable, streets, containing data. Whereas this streets on the left is just a string, which is just kind of the label of the column. So I could have called this anything. I could have called it like Southside Streets if I wanted to. But it seemed a little silly to call it Southside Streets because I already know this whole table is going to be called Southside. So it's obvious or Southside Streets. So that's why I just said let's just call it streets. But it's just whatever you want to call it, really. Okay. Oh, how do you name the table? You just assign it to a name. So you just do Southside equals this, and then now it's contained in South. So this entire table is now contained in Southside. So that's kind of how you can give a name to the table, I guess. Yeah. All right, let's continue. So now that we kind of seen different ways to create a table, you can read it from a spreadsheet, you can create it from scratch. We've seen a few different operations like where and drop and select and sort. And so now let's try to combine everything that we've learned in an actual example. So this is pretty cool. So we're going to kind of go back to 1900 for this and do an experiment alongside W.E.B. Du Bois. So I don't know how many of you are familiar with him, but he's just accomplished a lot. He was a historian, activist, but also what pretty much everybody here today would call a data scientist. Also founder of the NAACP. And so back in 1900, you know, this country and really the whole like kind of Western world was, you know, even more racist than it is today. And, you know, things were really bad. There's like a lot of lynching going on, like segregation was just the norm, you know, and so Du Bois set out to kind of change the public perception about Black people in the whole world, really. And so this was like a really big opportunity to do that. So, you know, there's this Paris Expo where people would come from all around the world and just share all kinds of really amazing things. And so he wanted to use data to try to change the public perception about the world, essentially. And so he filed a bunch of patents, took a bunch of photographs, made a bunch of graphs by hand, which is like crazy to think about because we're doing it in Python, but he made them all by hand. And so it's just a lot of work, but yeah, and so that's what he did. And so we'll kind of look through some of the stuff that he actually presented there. So to start, we're going to look at one of these graphs that he created. So I think I'm going to have you take just a couple minutes to just try to look through this graph. It might be a little bit hard to read, but just try to look through it. It's a really nice graph, and just try to see if you can understand what's going on. So we'll talk about it in a couple minutes. But just take a couple minutes to just look through everything. Okay, so any thoughts on what this graph is trying to convey, or what is it saying? What do you guys think? Unfortunately, I don't think I can. Oh, I can zoom in a little bit, I guess. But, yeah, that's the most I can do. Okay, income of families and what they spend their money on. Nice. Okay. What the average family spends their money on. Okay, you guys are already going like the next step. So you're not even just describing what it is, but actually what are the insights, which is really cool. So some people are saying, you know, people with higher incomes spend more money on stuff, you know, like other things. So that's pretty cool. Yeah. So, you know, what you guys are doing is, it's really great. So, I mean, there's kind of two things here. One is kind of just, you know, what is this data showing? Just kind of from a kind of just descriptive perspective. And then, you know, going even deeper and saying, okay, how do I actually infer this data? What are some of the interesting insights from that? So it's cool that you guys are already doing that. That's great. So yeah, so just to explain it completely. So we have a legend up here at the top. So we have like rent, food, clothes, taxes, other expenses, you know, like savings or just kind of, you know, any other expenses you might have. And then on the vertical, I guess like axis, you could say, we have different classes of people in terms of income. So notice here he says these two are considered the poor class, then you have the fair, comfortable, well-to-do. And on the left here actually specifies how the classes were created. So, you know, I think this might be like annual or monthly income or something like that. And then we have how much they're actually spending per month as well. $239.10, $249.45, and so on. And then essentially what we're able to see here is with this legend is we can see kind of the breakdown of how they're spending their money. And so in this kind of the lowest class in terms of income, you know, 19% of their income is spent on rent, 43% is spent on food, 28% on clothes, not that much on taxes, and 9.9% is left for like savings or other expenses. And you can just kind of see how these kind of breakdowns change as you kind of go up. So that's what this is conveying. And so what we can do is we can actually take a look at this data in Python. So we actually have access to this data. And so let's take a look at it. So we have it here in a CSV file. And someone asked, a few people asked, like, what is a CSV? So CSV stands for comma separated values. And so I can just show you with my screen, hopefully, what this data set actually looks like. Like, what does this file actually look like, this file itself? So hopefully you guys can see this. So these are called comma separated values. So in this first kind of row, you have the names of or the labels of the columns, say like class, actual, average, rent, food, clothes. And so notice how they're all separated by commas. So basically the commas let the computer know that like, okay, there's a new kind of column there. And then if you go to the next line, it's kind of going to the next row. So then you have 100 to 200, and then 139.1, and so on. So I wouldn't worry too much with the details here, but the basic idea is that CSV is a great way to store data that you would want to represent in a table using just commas. And it's just kind of an efficient way to store data. So that's what that looks like. And so if you have that CSV file, you can read it in using table.readTable. And so we'll do that, and we'll assign it to name Du Bois. And we'll just take a look at what this looks like. And so yeah, we kind of went over these already, but we have kind of this description of class, which is kind of how they made the buckets, the actual average amount of income, and then kind of where does that income go? So, you know, how much goes to rent, just like 19%, how much goes to food, clothes, taxes, others, basically like savings or discretionary spending. And then we have this kind of bucket. It's almost like a, you know, what does this mean in English, bucket? So, you know, he's considering these two as poor, these two as fair, these two as comfortable. And the last one's full to do. Cool. So now we have it in a table. And so one question is, you know, which group, or which class, I should say, spends the highest percentage on rent? And so actually to answer that question, let's take a look at this, right? So rent is the black value here. So it's, you know, it's not too hard to see here that 23% is the largest one. And so we have 300 to 400 on rent here. So that's the category or the class that spends the most. But if we want to actually figure that out in Python without looking at this graph, how do we do that? So we have this table of Du Bois. How do we actually figure out you know, which value here corresponds to the one where the rent is the highest? So any thoughts on how we could maybe try to do this? So let's try to use the functions that we've talked about so far in class. So some people are saying sort, okay. So yeah, let's try that. So let's do Du Bois, and then let's do .sort, and then we'll sort by rent, because that's the one where we want to look at, you know, who's paying the most on rent, who's paying the least on rent. So we can do sort, and then we can do descending equals true, right? And so now we have our table, and now it's sorted by rent. So now we can see right away what the answer is going to be, right? So it's going to be 300 to 400, because rent is at the top here. So this is clearly the one that's the class that's spending the most on rent. So now that we have that, we want to actually grab this particular value though. So how could we do that? So we have this table. Yeah, select. So if we have this table, now let's select just the class column, right? So now we get that table, we've sorted it. Now we select just the class column. And so now we have, you know, everything here. And the last thing we need to do is, well, actually, instead of select, we should use column so we can grab it. So if we do column class, that gives us an array. And so now we have the elements of the class, the sorted, I guess, by rent class in an array, and then 0th index. So we do .item 0. And so this will return 300 to 400. And so this is kind of one way to do this. Obviously, there's other ways you could do this, but this is just one of the ways, using just kind of the different methods we talked about. So here we're basically using sort, column, and then item. So any questions about how we just did that? Yeah, can I repeat it? Let's do it again. So firstly, we said we're trying to find the class where the rent, they paid the most on rent in terms of just proportion. So first we said, let's actually just sort this entire table by rent. And we said descending equals true because we want the maximum rent to be at the top. So this particular class spent 23% of their income on rent. So once we got that, then we said, okay, now we sorted the table by rent. We mainly just care about class. So let's just take the class column because we're really trying to find the class of the person or the category that's spending the most on rent. So we just take the class column and we want the person who's spending the most. So that's just going to be the first one. So that's why we do item 0. And so that gives you the 300 to 400 class. One question was, could we just do like show 0? So yeah, I mean, if you sorted this and you just did show 0, or actually it should be show 1, sorry. So you could show 1, but that shows the entire row. And the point was to get to just this value, the 300 to 400. So technically this isn't the right answer because it's giving you the entire row. We wanted just the value of the class of the row that corresponds to the highest rent. So. Okay, cool. So that's how we did that. Another example that might be kind of interesting to do, let's see, we have some time, is to look at some of these other columns and see if we can combine them together. So let's actually now try to look at food and try to understand how much people are actually spending on food in dollar amounts. Because we don't actually have that data here. Like we have the average income of each of these groups, and we have what proportion of that went to these different categories, but we want to actually calculate the actual amount, the dollar amount spent on food per month on average. So how could we do this? We could do Du Bois, thanks for catching that. Du Bois with an underscore, dot column, and we have actual average. So this is the actual average income they had. And then we can also look at food. And so this is going to be the column of the kind of percent they spent on food. And so what we can do is if you want to get the actual amount spent, we can just multiply these. So we take the dollar amount of their income multiplied by what proportion of that income went to food. And so now we get an array of how much actually spent on food. So if you look at this 59.8 corresponds to the first class. So the kind of the 100 to 200 class spends $59.8 a month on food. And the next class spends $117.2 on food, and so on. But it's kind of hard to kind of go back and forth, looking up and down, scrolling up and down. Might be nice to just add this into our table. And so we can just do that. So first, let's actually give this a name. So we're just call this food dollars. So I'm just going to food dollars equals this thing that we just created, which is their income times how much they spend on food. And then we're going to do Du Bois with column food. Let's call it food dollars, and then we'll pass in food dollars. All right. So now if you run this, now we have this table, and then we also have this now food dollars column at the end here. So now let's say we're just trying to understand like stuff about food. So what I want to do is I want to take this Du Bois table and then only select the columns that are related to what I care about. So let's say I just want to look at class, actual average income, the food percentage, and the food dollars. I don't really care about like taxes and all the other stuff right now. I'm just looking at food. So if I run this, I get an error. So any thoughts on why I'm getting an error here? So I took this Du Bois and I tried to select class, actual average, food, and food dollars columns. Okay, I spelled food wrong. Okay, so that's a good catch. Let's try that. No, still not working though. So that was a good catch. That was actually, I spelled that wrong. Any other thoughts? It's a different table, nice, yeah. So if you actually go down here and look at this, right? Let's try to look at this error message. So it says the column food dollars is not in the table. The table contains, these columns. So the table contains class, actual average, rent, food, clothes, taxes, other, and status. It doesn't actually even have anything related to food dollars. So why is that? What happened here? Well, we wrote this line without actually assigning this to anything. So this line, for some reason I'm not able to select. This line here, all it does is says, let's return a new table that is equal to Du Bois plus the food column in it. What you need to do is if you actually want to update this, we need to do Du Bois equals that expression. And so now, if we run this, now it's actually fine. So this is a really common mistake. It's going to happen, but just a good way to check. If you see some weird error where you're expecting to have kind of like a column there that wasn't there, it's probably just because maybe you forgot to add it. And so this is just really important. Make sure you're really kind of intentional about assigning things back into the same name if you do want to actually update that, what's contained there. All right, I think we'll stop there. We're a little bit over time now. But if there are any other questions, we'll stay around.